everyone. Thank you for joining. One of the biggest questions that we get asked with regard to HPCC Systems platform is why HPCC Systems and not something else? A clue here. The answer is pretty much in the topic on the top, right? So one of the things that we're going to explore today is how HPCC Systems has been developed for a specific use case. If you're looking for solving that specific types of use cases, then HPCC is really a system that you want to take a look at, right? The other two qualities are also important in the sense it's really a one-stop shop. Everything is built into the HPCC Systems platform, and that's all you need. So it's simple to code to, simple to maintain, and that is important, especially if you are a new company, a startup, and you want to get started very quickly. It is important to make sure that you have a simple surface for execution and you can depend on the quality of the product so that you do not get stuck and you do not start being exposed to a loop of support. Being a simple and easily maintainable system is very important. Now, last but not least, obviously, it's free and open source, but free and open source does not mean that it is not enterprise quality. HPCC is currently used by thousands of servers across the world and many customers. So if they are having an issue, then obviously HPCC will need to be supported so that the quality is maintained, right? So to that effect, just because we support these types of customers and they are solving critical problems on a daily basis, the quality of HPCC is the utmost importance to us. And you can be guaranteed that whatever you see and whatever you test and use is enterprise grade and quality. And obviously all this comes free and it's open source. We'll cover a little bit of that a little later. So I'm going to go through some of these bullet points in a little more detail, just to explain to you why HPCC is really, made to solve certain problems, or it is simple to use, and obviously it's enterprise quality. Okay, so let's start with the first bullet point that I address, in the sense HPCC is really made to solve a certain problem. Let's take this particular use case. This is a use case that was reported by an insurance company out of Oklahoma City, real use case. You see all these dots here, the bigger dots, were really accidents that were taking place in a certain location in Oklahoma City. And the insurance company did notice that these accidents seem to be odd because they occurred at a certain location, which is very close to a hospital. And in many cases, if you look at the accidents itself, they had a lot of participants in it. In a single accident, there were like 6 people, 7 people, 8 people, so forth. It almost looked like it was deliberate accidents that were being caused to claim insurance, right? So insurance fraud. But the insurance company was not able to pinpoint exactly why this was happening. They were not able to pinpoint fraud either. All that they recorded was there were these accidents, and then they had a hypothesis that these accidents seem like fraud. But again, just because you think or feel like it is fraud doesn't mean it is fraud. So they wanted to prove out this concept, and they obviously reached out to LexisNexis Risk Solutions, which is the company that analyzes these types of use cases. and behind the scenes, obviously, we use HPCC Systems as a platform, and wanted us to see if we could solve this particular use case to them. Okay. Now, before going into how the use case itself was solved, one of the key things is to understand the data aspects of how this data that is relevant to this particular use case is ingested and then processed through the platform and then provided as an analytic solution, which is then used to solve the problem I just stated, right? Now, if you look at the insurance use case, we acquire data from thousands of sources, 10,000 or more sources across the United States. Examples of these sources could be public records databases for property records, right? So if you buy a property in the United States, that property record is public records. So we have access to those public records, and obviously with that public records comes who is the owner of this property, right? Who is this owner or owners of this property. And then we have drivers vehicle records from the drivers motor vehicles records across all the states. So we are talking about 50 states with 50 proprietary different formats and ever-changing schemas. So we have to acquire this data, process it, and then bring it into our processing environment for processing, right? But it's across the board. And then we are talking about insurance claims records, public records like criminal records and bankruptcies and so forth, right? How does all this information come together and collate to what we want from linking technology, right? So once we get this data, it goes through the process of integration and cleaning, normalization, and so forth. And then the final output of this is, okay, who is this person that we're talking about? And what are the relationships this person has to either assets that he owns in the United States or relationships to other people in the United States, right? So we're kind of, what we're trying to do is, can we get a 360 degrees view of who this person is? So that's the integral problem that the HPCC systems is designed to solve. If you have similar problems to this type of problem, then it's perfectly made for solving these problems, right? And ultimately, if you look at it, on the outside of it, once we have these relationships and everything linked together, we have a rich social graph of information of how a person is related to either assets or other people. Then we can use that to solve the problem I just stated in the earlier slide. And in this case, as soon as we took the data points that the insurance company, the Oklahoma insurance company, provided us with regard to the accidents, and we layered it on top of our data assets, our social network graph, you could see immediately how all of these accidents were actually linked to each other, right? And once we did the investigation, we could see that this particular use case was a fraud that was created by two big, large families, right? So families in this case are people and relatives and friends getting together to create a very complex fraud, insurance fraud. And they were all working in unison to create this fraud. Now, this type of use cases are really hard to solve if you do not have both the technology that can link all this information together in a rapid fashion, as well as some of the data assets that we spoke about with regard to collecting and processing this data. So both have to be brought together to make it happen, right? But once you have hands on the data, let's say you're a startup and you think you want to solve something in this relevant field and your kind of use case is similar to this type of use case, HPCC is perfectly made to do that, given the fact that you have access to the data assets that you need to process this data. Okay. Now, going back, look, HPCC has been around for a long time. We developed HPCC in the year 2001. There's a good story around how HPCC started. It was started because one of the earlier customers for LexisNexis, they had a very unique problem. They were trying to determine, this was a huge credit bureau that was trying to determine the number of people that would go bankrupt in the beginning of the month, right? So they wanted on, let's say we're talking about February 1st. On February 1st, they wanted to predict potentially how many people would go bankrupt in that month, right? So they did have a process to actually do this. They had, they created an algorithm which ran on their Oracle database and mainframes. But the problem is it took literally 25 days to run, right? So if they ran it on February 1st, imagine they would get the results back 25 days later, right? That's almost the end of February by then. So it is not a good solution for them. So they approached LexisNexis at that point and said, look, LexisNexis, can you solve this for us? We did acquire some key talent from the United Kingdom who are working for Bolan International and other companies who are compiler developers. And once we got them, we built this first versions of the HPCC platform in 2001. Whatever problem was being solved in 25 days, when we ported that to HPCC systems, that problem was solved in 4 hours. So literally, the company that wanted to solve the problem and it was taking them 25 days could now solve it within a day. So satisfying that particular use case, and that was how HPCC was actually invented way back in 2001, way back before anybody had heard about the big data ecosystem and big data hype around when Hadoop came into play in 2010 and 2011. Now, over the years, HPCC has expanded. LexisNexis as an organization has acquired some critical companies. One of the critical companies that did acquire in 2007 was a company named ChoicePoint. They were really into processing insurance data. Again, ChoicePoint had similar difficulties with regard to processing large-scale data for insurance companies. But once that was ported to HPCC, again, you could see the progress that was rapidly made to surface some of these solutions to the insurance companies. We went open source in 2011 just because we said, you know what, if we do not go open source at that point in time, this particular product might have to compete with other products in the same landscape, but we will not have the input from the open source community to do so in an equal manner. So that is the reason why it was open source in 2011, to gain from the market, to gain from the community, to understand how to make this a better product and so forth. And from there on, we have expanded tremendously over the years to make it to where we are currently. A cloud-ready product, works on Azure, AWS. It is cloud native from the perspective. It's all built into Kubernetes architecture, and it can be deployed in a cloud designed setup on AWS as well as Azure. Okay. Now, going back to the core problem, what are we trying to solve? Again, it all comes back to, in our case, what we call as the linking problem. If you take a person, how is this person related to other assets, whether it's vehicles, court records, homes, property records, all this, has to be understood, because all of them relate to solving a certain kind of problem, right? Once we know the associations, then we know how the associations are related to other people, for instance, right? So an example would be, if you own a property and that property is owned by somebody else, then we know that there is a relationship between these two people. Once that relationship is established, then we can create kind of the social network graph around the person in a very, very granular fashion, right? It is also important to remember we are not like a social media organization like Facebook or LinkedIn where you go in there and provide the relationship information. These information that you see that we have to explore is really inference information that we have to build. It's not something like where a consumer comes to us and says, look, I'm related to this person and I own these assets. No, we go and acquire these public records type of data and then build this rich relationships so that we can then explore potential fraud and help government organizations and organizations across the world to come to some critical solutions around people and their assets. Okay. Now, how do we do it? As I spoke earlier, we have to understand what are the relevant information. Does it make sense to capture their criminal records, bankruptcy records, property records, driver motor vehicle records, for example, accident records, and so forth. Plus, did this person have a DMV or DUI? Or did he have a speeding ticket? So forth, right? So all this information is relevant when we start building this rich graph of the person. Okay, and once we acquire the data, now we have to go through the process of performing some critical tasks. And when I talk about critical tasks, I'm talking about how do we understand what is the quality of the data. That means we have to do some level of profiling, cleaning once we understand the quality of the data to make sure we have clean and standardized data. And then the most complex part is relate this data to other assets, right? Whether it's a person to assets or person to other people, how do you bring all this data in a rich and accurate fashion? We do not have the luxury to make mistakes. We have to be at least 99.99% accurate with regard to anything that we come across as far as identifying a person and identifying the relationships of these people, right? So once to do all that, again, we need to have a platform that is kind of custom built to do these steps, profiling, cleaning, linking, enhancing the data, and then delivering it to our end customers. Exactly what the HPCC platform is made to do. Okay. Now, this is the same graph that I showed earlier, but now I want to go into a little more details on what the platform looks like internally, right? So once we collect data from the outside, as you can see on the outside, it looks like the wider part of the funnel, right? If you look at this diagram, it looks like a funnel diagram, and this is kind of the input to the funnel, the wider part of the funnel, where all these data assets in their structured or unstructured formats, they are then pulled into this funnel. As soon as we enter the funnel, that is where a technology that or component that HPCC has is relevant. And this component is called as Tor. Tor is really made to crunch large volumes of data, go through the process of profiling, cleaning, enhancing, and linking. That is exactly what the Tor component is designed to do. And once you go through, as you can see here on the top, it goes through the steps of linking and enhancement, and then and then at a certain point you have rich data that you want to now share with your customers. And there's a few ways in which you want to share this data with your customers. One way is potentially they send you a relevant batch file, and then you send them back the results in a batch file. But in many other cases, you're looking at providing this particular data or data querying with a real-time query interface. And that is where the second component of the HPCC Systems platform comes into play. This component is called as Roxy, and Roxy is your data delivery engine that delivers the data in real-time fashion to end customers. So they can they pretty much have like an API interface to do queries on the data that you have processed, and that is then served to your end customers. Now, the key things that you want to be concerned about is, how difficult is all this? Now, look, Tor and Roxy are closely aligned and closely built together. So whatever happens on Tor is now processed and available on the Roxy cluster without doing too much effort at all. So it's linked nicely together, and it is built in the manner in which this particular integration and use case has to work end to end, right? As I said earlier, it's kind of custom made for these types of use cases. So if your use cases kind of match this particular use case that I'm talking about, then you'll love the HPCC Systems platform, because it just works out of the box, and you can use it straight away to solve these use cases. Another relevant example, completely different example from the example I just spoke about with regard to a person data and the fraud use case that we talked about. When you go to a restaurant currently, you might like something that we like. Let us say that you ordered a hamburger and you love this hamburger, but you want to know more information about what is this hamburger made out of. Is this organic meat? Is this organic contents? What has gone into this, and where was this sourced from? If you want all that type of information, then the foundation is we have to have machinery that collects this type of information at the time of farming itself, right? How are these grains grown in the farm? What particular pesticides are used to grow these grains, if at all there are pesticides that are being used. Same thing with farm animals as well, right? How are they fed? What are they fed? All this information has to flow in from what we call as farm management systems. Now, if in the United States, all these types of agricultural products and agricultural sourcing has become very sophisticated in the last few years. And if you look at it, how farming works, in most cases, it is based on implementing farm management systems. How does this farm management system works? Okay, when we talk about collecting information, there is a top-level farm management system that collects this information and brings it all together. Then how does it do it? Using sensors in machinery. And what are these sensors really looking at? They're looking at a lot of things, right? Whether the sensors are on animals or whether the sensors are in soil, looking at the richness of the soil, what is the fertilization level of the soil, and so forth, right? So all these details are really important to understand. Number one, what is the current condition of this agricultural product, and how can we make it better in the future? And so forth, right? So then, there's other related data with regard to the weather. Is it getting enough rain? What is the potential for the future, in the sense, how can we predict better weather in the future? All these aspects also come together for us to be able to understand this particular product, right? So in my previous example, we talked about a person. Here we're talking about an agricultural product like a grain or an animal and so forth. So how does all this come together? It comes together in a very similar manner to what we spoke about earlier with regard to the data aspects of linking, cleaning, processing. All the same things that we spoke about earlier also applies to this particular use case. Okay. Very quickly, again, to summarize, we send this information to an HPCC platform. Once we go through the process of linking, cleaning, analyzing, this product and output is available to the people on the field. So if they want to improve this product, how do they improve this product? Let's say they can make those informed decisions very quickly. Now, the next level of this is how do we provide the same level of information to consumers like us who visit restaurants, who are consuming these products, and we want to understand what is the impact of this product on our health? What is the impact of this product on the climate and so forth? Modern day questions that need to be answered. The only way we can really make this relevant is if we have the system in place to bring all this information together and analyze it and provide the answers. Okay. Now, let's step back a little bit and just understand some of the basic concepts of HPCC. So there is one question, by the way. Let me. Okay, so perfect. I'm going to Steven. I'm going to talk about the tools in the next few slides, and I think when you see it, you like what you see. So again, going back to the foundation, just to spend a little bit of time, you have the Tor cluster and the Roxy cluster. As I said, Tor is really made for processing batch-oriented data, doing the cleaning, normalization, standardization, linking, and bringing it all together in a rich fashion. Once you have the data and it's relevant now and you want to deliver it to your customers, then you have the Roxy cluster. It's kind of your API cluster. Once your API is ready and it's ready for query purposes in real-time fashion, then Roxy takes over, right? But the key to understand this system is that they are well integrated. It's not one or the other. It's both working together in unison, right? Now, there is a programming paradigm called ECL, which is used to actually program this cluster. When you do these types of jobs, when you deploy these types of queries on these two environments, you use ECL. Many people question the fact that, okay, this is it's kind of a different language from the language that they're more used to, whether it's Java or Python. Yes, it is different, but at the same time, this is a very data-centric, data-oriented language. And what I mean by data-centric, data-oriented language, I'm going to cover that in the next few slides. And then it'll become more relevant there. Now, let's compare ECL to something that is more relevant, not compare it to like a programming language like Java or Python, because that's not apples to apples comparison anymore. When we talk about ECL, it's a fairly data-centric language from the perspective, if you're thinking of processing data from a perspective of, look, I have a table of records. Now I want to transform all these records collectively to a different format. How do I do this, right? If you're a Java programmer or Python programmer, then you're thinking in terms of looping through these records, reading these records, and then writing it out to a different file. But in the case of ECL, in the case of an equivalent language like pandas, you're thinking of more from a perspective of functions, right? Functions that actually automatically loop through your data. You're not really asking the programming language to loop through your data explicitly. You already assume that it's going to loop through the data, and then you're going to apply kind of either transforms or you're going to process this data through sorting or tables and so forth, right? So you can see from a perspective of ECL, and if you compare that to something like pandas, you have kind of similar concept. What is in pandas a data frame? In ECL, it's called a data set. When you do a merge, that means you're merging two tables and bring that together. Then you have a join condition in ECL. Join is like an SQL join as well, right? You're trying to join information from two tables and so forth. The append is more if you have two tables or two files and you want to append the data together, then you do an append. So table is for more of an aggregation of data and so forth, right? So you have all these types of key functions that somebody will have to learn and use ECL and HPCC in that context. Now, coming back to the question of why I said it is simple, really all the person who's working in HPCC needs to know are these functions. That is it. If they understand ECL, when we say if they have to understand ECL, we're talking about understanding these constructs, really. And once they understand these constructs and they know what these constructs are actually doing behind the scenes, that is it. It's as simple as that. Once that gives them the power to really work with HPCC in an easy manner. So now to talk about an example, right? So ECL is kind of a data-centric language, right? So let's take a specific example here. Now, I have what we call as an inline data set, and the data set, as you can see, has a layout specified to it, right? Now, when we talk about any processing of information within an HPCC environment, HPCC by itself is schemaless. It does not need to understand that there is a schema already present, right? If you look at ingesting data into databases, for example, you always have to have a built-in schema already to ingest data into this database. In HPCC, it is not the case. It is a data lake environment. Obviously, data lake means that it is schema-less. So the schema is really determined at runtime when you actually are processing this data. Now, for simplicity's sake, I've taken an input data set that is fairly simple. It literally has 3 fields, and it has many records in it, right? Now, if you want this same data set to be read from a file, very simple. All that you need to do is use this statement here, which is really a data set, but it's referring to a file that is there in your system. And this file can contain millions or billions of records to do exactly the same thing. The code does not change. Just changing the data, the same code will transform all the records in your system, right? Now, just to go through this particular example, so you have an input layout that you're saying is your data set n. In this case, it has a datetime field. It has 2 decimal fields for fair and distance. What we are trying to do here is really extract this information out, separate the date time into just date and time, like how you see that in the output here, right? So that's what we are trying to do. Very simple example. So how do we do that? There's, as you can see, there's no looping condition, nothing, right? There's no specific, okay, go through these records, read these records, do this transformation. All that you're doing is saying project. Project for us is really implicit loop, right? It does what it does is it is going to go through all the records in your data sets and then apply what we call as a transform. That means it's going to take all the input records and perform a transform on those input records and convert it to an output record set, right? And if you look at what it's doing here, it's literally extracting out different parts of your date and time field and then formatting it slightly differently. And if you look at the output, here it takes this input and the output looks like this, right? So it has extracted out the date part and it has extracted out the time part into separate fields. Simple example just to show you how powerful and easy HPCC is. Now, if you have billions of records in your data set, code does not change. It's the same exact code, and it'll still work in the same fashion. Yes, you might have to add more processing power to add more servers, depending upon the size of your data, but there's no really changes to the code. Another key point I want to make is, as I said, this is a very data-centric language. As far as you can understand data and how to work with data from a data analysis perspective, it's a perfect language for anybody to learn. The other thing is, there's only a few things that you have to learn, right? As I said, just like project, you have, the other functions that are really relevant: normalize, denormalize, join, sort, group by, and so forth. So very few functions, and once you know those functions, then you become an ECL guru at that point in time. There's really nothing else to learn in ECL. Okay. Now, one of the key things or differences between ECL and other programming languages, as you can see, ECL, as you write code, your code looks somewhat different from what it is compiled to. On the right-hand side here, it shows you the actual execution graph. If you're very familiar with SQL, you understand what I'm talking about here, in the sense when SQL is compiled, it is compiled to an execution graph. In the case of the Oracle database, they call it an explain plan, right? So whatever SQL that you provide, once it creates that execution graph or explain plan, that actual explain plan might kind of look different from your code. And you can see that straight away in the code that I created here on the left-hand side, and compare that to what ECL is actually executing on the right-hand side, right? So the ECL compiler has taken all this code and made it more relevant in the sense, look, I do not have to explicitly read all these, data by using different steps like what I've stated here. Rather, I'm going to, as soon as I read the file, I'm going to apply the transform as I'm reading in the file myself, right? So I do not have to first read the file separately and then apply the transform. So you can see that it has optimized this to say, as soon as I read these records in, I'm going to apply the transform, and then it's going to also do some optimization. Saying that, look, these records are very few records. I can just keep them in memory and process these records very quickly. And that's what it's doing here, right? It just does a first end saying, I can pull all this into memory and then simply output the results, okay? So that is very important to understand, because ultimately anything that you do in ECL, any code that you write in ECL is then optimized into an execution graph. And how does the compiler determine this is the execution graph? It is based on several factors. One is the computation power that you have, and the second is really the data workload that you have. What is the input structure? What is the size of your input record set? Also, all that comes into play with regard to it determining that this is the way to actually create the execution graph. So based on those factors, it can determine whether it can execute this workload in memory, or it has to actually do the processing in a hybrid fashion, in the sense stream it from the disk and process it, and then push it out to the HPCC platform. Okay. So 3 things that you have to remember, really. ECL is declarative in the sense that you do not specify how it has to actually work. You just specify the what you want done, and the compiler will determine how it actually has to be executed, right? So that's the key thing. It compiles it to an execution graph, and that graph is optimized automatically for you. Okay, now Steven asked earlier, what are the tools that are available within the platform, and what is open source and what is not open source, right? Everything is open source. Every tool that you see here is open source and available for you to use, okay? It starts with the IDE, which is a plugin into VS Code. Modern IDE gives you all the syntax highlighting, compilation features, formatting of the code, and so forth, right? So it's built into VS Code IDE, and that is what you will typically use. We do also have a legacy version that is really made for Windows platform, but I would simply state that it is a legacy version of the IDE. So we have a modern IDE to develop the ECL code for processing data. Now, in addition to that, we have, once you have this data and the data is now available within the HPCC platform, many cases, the data scientists or people who are processing or working with the data, they want to visualize this data and look at the data, look at the shape of the data, right? So we have a visualization tool that is really relevant to the HPCC platform. It's called RealBI. It is the visualization tool that directly integrates with the HPC platform. So any output that you process within the HPC platform is then available for you to visualize very quickly in real BI. Now, once you get beyond the state where it is relevant to the data scientist and you want to process this data and make it more available in enterprise BI tools like Power BI, there are other ways to make that available through your enterprise BI tools like Power BI, right? So real BI is not a competitor necessarily for Power BI or your other enterprise BI tools, right? It's more of a tool that is used by data scientists to quickly visualize information that is there in the HPC platform and see if the shape of the data is really what they're expecting. But once they move out of that and they want to now progress this to relevant dashboards that are now available to customers, there's several other integration ways that you can make this available on Power BI and other tools. Okay. Now, if you want to work with an IDE that is more cloud ready, yes, we have integration into the Gitpod IDE, right? So that's available where you can run this entire ECL workload within a browser. Then we have the ECL Watch, which is kind of your playground area, but more importantly, it is your administration interface. So anything that happens on the HPCC workload with regard to processing data and execution of your execution graphs, all that is available on the ECL Watch admin interface. Okay, and one of the key things you'll use the ECL Watch admin interface is to do debugging. So once your data workload executes, remember it's working probably across hundreds of nodes potentially, right? So you want to explore how your data is optimized, and maybe adjust how the data is distributed across these nodes to make it more efficient. You'll use ECL Watch to do that type of debugging and analysis. It's a fantastic interface to make that happen. And then we have built-in tools for data profiling as well. It's all built into ECL Watch. As soon as a file comes in, we can let ECL Watch know to turn on data profiling automatically. So once the file comes in, it's automatically data profiled. So you have all the relevant information with regard to how good your data is. What is the quality of your data? Because ultimately, if you make some assumptions on the quality of the data and then you just process the data, your outcome can be completely wrong, right? So it's an extremely important step. And we have noticed that over time. It's been our experience. We have taken our experience and built this into these tools. Now, last but not least, Tombolo. It's your data cataloging tool. Tombolo is kind of a newer tool that we have built recently, and it's still being evolved. I think the newest release of Tombolo is going to be made available in the March, April timeframe. So Tombolo is a tool that you use for cataloging all the information that is there in your data lake to start with, right? You want to understand who owns these data assets, and if you make changes to these data assets, whose approvals should you take, and also as it evolves, as these data assets evolve in your data lake, what is the governance around this, right? What is the compliance around this data assets? For example, if you have a field that you're processing for, and that field happens to be a social security number, it has to be taken care specifically. If it's a credit card information field, it has to follow some compliance rules around how it has to be encrypted. So where are these rules, and who monitors these rules, and how is it actually applied across your workflows, right? So somebody has to track that, and that is exactly what Tombolo is used to doing. It is used to cataloging, first of all your data assets, providing the rules around how these data assets has to be managed, and then ultimately, once you orchestrate your workflows, which Tombolo also provides, because it needs to understand who is executing what job for what purpose, then it creates the entire end-to-end setup for processing your data, right? So in most cases, when you're dealing with sensitive data, you have to make sure you're in compliance to various standards that are out there, right? If you're dealing with drivers data, if you're dealing with social security data, if you're dealing with medical healthcare records data, there's several different laws and compliance requirements around all these data types that you have to be concerned about. Yes, you can process the data and you can come up with a solution, but ultimately, if you're not disciplined enough and if there's an issue, then you pay a heavy price for that. And that's what Tombolo has been built to solve. All these tools are open source and available for the people to use across the board. There's nothing that we say it's proprietary and only LexisNexis, Risk, or Alex organization uses. Everything that we use is available to be used by the outside world. Okay? And again, going back to what is the type of information that is available, there's a lot of information that is available. Again, one of the things that we are doing is trying to make this information that is available out there on the website and the other locations with regard to the documentation, bring it all together in a very systematic manner. Jessica Lottie and our marketing group is working very hard to bring all this together in a very concise manner so that it can be delivered to folks on the outside very quickly, right? You should start by exploring the HPCC Systems website and go from there. And even there, we are obviously evolving all the information that is there on the website as well as we make progress. We are also building, tools on the cloud so that you can literally explore HPCC as a one-click solution. Like literally, if you have an AWS account or an Azure account, you click a button and it'll spin up an HPCC for you, and you can start playing around with it. Okay. And I think that is pretty much it. So as you recall, I had literally three things that I wanted to talk about of why HPCC, right? One is it's custom made to solve certain types of workloads. If you think the workload is entirely different, like, let's say you're streaming data and you're bringing all this data and you want kind of real-time outputs immediately, maybe HPCC might not be the relevant system. But if it is a system that is based on profiling, cleaning, understanding your data, linking this information together, and then providing a solution, it is a perfect fit for that types of use cases. So you have to be careful with what use cases that you want HPCC to solve. And if it fits, then it fits perfectly, right? And you really want to use HPCC for that. Then it is simple. You saw the examples of the ECL language. Many people ask me, oh, this is a new language, this is a proprietary language, so forth. Look, if you know these 6 functions, that is all you need to know. If you know the 6 functions well, then you know HPCC ECL. How difficult is that, right? So it is very simple to use. And last but not least, it is enterprise grade. It is being used by thousands of systems worldwide, right? And many customers, yes, obviously, we cannot talk about some of the biggest customers openly, but trust me, it's being used across the board, in an enterprise scale for many customers. And if these customers happens to see an hiccup within the system, then it's a big deal, right? So that's why it is important to understand this is running live, real workloads that are critical to these customers, and that's why we claim that it is enterprise ready. So if there's something that needs to be fixed, it is fixed straight away.